Good evening, I'm Jeff Weller, 1/3 of your WeatherWatch 12 weather team. Thank you for joining us. I'm joined by morning meteorologist Tyler Moore and weekend meteorologist Devin Biggs. It's easy to talk about the weather. It always seems to be around us. It follows us everywhere. It's also an easy go-to topic when conversations get a little awkward.
We're lucky enough to experience 4 seasons up here across the Northwoods, and there's seemingly no shortage of weather headlines through each season. Tonight we'll take a look at some of those headlines. We'll also count down our top 3 recent weather events.
We begin with some heat. Number 3 on our list is the hot summer of 2018.
We usually don't experience a lot of heat across Wisconsin. We usually experience a few hot spells during the summer. The summer of 2018 had a unique setup in which we saw many days in the 80s and 90s. Some areas even saw record highs too. We took a look at our climatology sites across the viewing area, including Rhinelander, Wausau, and Stevens Point. What we found was that late May was the unusually hot point in the summer. Rhinelander and Stevens Point set new records. Rhinelander set a new record on May 26th and May 27th of 93 degrees. The old record was 90 degrees on May 26th and 91 degrees on May 27th. Wausau got close during that same time period but fell short by a degree or two. Stevens Point tied the record high 2 days in a row.
A lot of warm temperatures, and daytime highs were, pretty warm, but they were especially notable nighttime low temperatures that were just well above average, and that is probably attributed to the fact that there's just more moisture in the air.
The warm lows of 2018 were reflected on the summer averages. That is the average low for the entire summer when calculating all the lows together. Normally we're supposed to be in the low 50s. That summer we were in the mid 50s. When comparing that, it isn't quite as warm as other summers, but it still ranks up there. Now let's look at the average summer highs when all the high temperatures are averaged together. Most summers were in the mid to upper 70s. We had summers in the low 80s. 2018 made it up there, but it wasn't the warmest on record. For the summer of 2018, high pressure was the culprit for all the trouble.
At least during the month of June, we had kind of a high pressure blocking pattern across the southeastern part of the United States. And what that did is it allowed for kind of a consistent flow of southerly warm air and moisture.
National Weather Service in Duluth says that this is a common occurrence during the summer months, but there were parts that was unusual too.
It's a fairly common summertime pattern to get that on occasion, and it can kind of that high pressure can kind of just sit there for several days and just keep a similar pattern going for a while. And so it's fairly common, but at the same time, we don't typically see intense flooding as much as we did in 2018.
A lot of the issues we had surrounds the jet stream too. National Weather Service in Green Bay says the jet stream has actually slowed down.
The jet stream is a little bit slower than it used to be, and that's due to the temperature difference between the Arctic and the tropics aren't as high as it used to be, so the temperature differences are lower. So the jet stream has moved a little slower, so anytime it gets nudged in a certain direction, it tends to stay where it is at for longer periods of time.
Not only is it slower, but it's also all over the place.
The jet stream is more wobbly than it used to be, so it rises further north and sinks farther south, so that's been giving us more extremes.
When dealing with hot and humid weather, that allowed plenty of flooding to take place in 2018.
In June, we also saw some pretty intense flooding across parts of upper Michigan into northern Wisconsin and parts of Minnesota as well.
The flooding part was the area that isn't normal.
We don't typically see intense flooding as much as we did in 2018, and so there was a little bit of uniqueness in that aspect, especially with the flooding, I would say.
We did see plenty of 90-degree days in 2018. We saw 15 days of 90-plus degree days. That's way above what we typically see. We did see many days with temperatures over 85 degrees too. That was also unusual. In the surrounding years, we usually see a couple of 90-degree days a year. So far in 2020, we are very low in that count with one 90-degree day in Rhinelander and a few days close to it. In northern Wisconsin, I'm Devin Biggs for WeatherWatch 12.
Of course, that heat is provided by the sun. Several Wisconsin companies have not been shy about trying to harness the intense power of the sun. But is the financial risk greater than the reward? We'll take a look. We're here in Two Creeks, Wisconsin. We're behind me. We're in the process of building an 800-acre solar farm that is going to be the biggest of its kind in Wisconsin to supply lots of renewable energy across the state.
Wisconsin Public Service and We Energies are committed to providing our customers and our communities with a clean energy future that is safe, reliable, and affordable.
Now, that's getting bigger with 2 large solar farms being built in Wisconsin.
The Two Creeks Solar Park will be capable of generating 150 megawatts of energy, and that's enough to power more than 33,000 homes.
This is all part of a goal to reduce carbon emissions across the state.
Our renewable and our carbon-free facilities are important pieces of our plan to reshape our generation fleet and reduce carbon emissions, reduce cost to our customers, and preserve fuel diversity. We have seen the efficiencies and the advancements in technologies really, go very far in solar energy, and again, particularly those large-scale solar facilities, which is why it does provide a cost-effective option now for our customers, and it will help us in that generation reshaping plan, and one of the goals that we've set of reducing cost to our customers in addition to reducing carbon emissions and preserving fuel diversity.
Some of the electricity used by customers are from renewable resources.
Right now, 26% of all the electricity that our customers use is generated by renewable or carbon-free resources and facilities. For us, really, it has been looking at the ability to provide our customers with that reliable and affordable energy that they need to power their homes and their businesses.
A recent trend will make the innovations more affordable.
Price of utility scale solar has dropped dramatically here in recent years, which does make it again a cost-effective option to serve our customers as we move forward. So the construction of the Two Creeks Solar Park really has been a multi-year process for Wisconsin Public Service and for our partners at Madison Gas and Electric. And again, at the end of the construction, which will be at the end of this year, we expect that construction will be complete and it will begin generating electricity for our customers by the end of this year. It will feature those 500,000 solar panels and be capable of generating 150 megawatts of energy.
What about the weather? We asked them how weather influences the project and process.
Wind speeds, wind directions for wind parks, the amount of solar energy that's present in a specific location for a solar park, and again, available land that's available to house and have those facilities located there.
We asked how energy is converted once it's captured by the solar panels.
That energy is then transferred and converted into electricity, and it's transported through underground electrical facilities and then onto the distribution system where we can then provide it to our customers.
A program already in place allows WPS and We Energies to collect solar energy for quite a long time.
At We Energies, we have a program called Solar Now, in which we actually lease space and install solar panels, and then the energy that's generated from those panels is provided to our customers.
Reporting in Two Creeks, Tyler Moore, WeatherWatch 12.
Certainly some interesting technology goes into harnessing and distributing all that power. When we come back, from record-breaking snow to intense summer rain, we'll look at why it's been so wet.
Welcome back. Years above average precipitation on the Great Lakes region has created more than a few problems. Maybe your dock is underwater or your favorite sandy beach just disappeared. Safety is a factor too. High water flow rates lead to uneven and dangerous ice conditions. Number 2 on our list is the record-breaking precipitation. We talked to the National Weather Service and the Army Corps of Engineers to find out more.
We see plenty of precipitation across Wisconsin, from snowfall in the winter that allows us to go snowmobiling to rainfall that we see in the warmer months. Both have caused lakes to reach record levels across the state. The decade of 2010 saw staggering increases in precipitation.
The 2010s, which is the last decade we just got out of, saw the most precipitation in a decade since we've been keeping records in the 1880s. And when I say we broke the record, it wasn't by an inch or two, it was by over 50 inches. So by more than 50 inches, we broke every single decade since the 1880s as far as precipitation goes for the decade.
Breaking all of those records did cause averages for the past 30 years to be raised.
We keep a 30-year running average for our normals for the 30 years. We say what's normal for today or this year or whatever. So because this decade was so wet, we're looking at an increase from the previous 30 years to the next 30 years coming up, which will include the 2010s, of over an inch and a half of normal precip for the year.
That increase in precipitation is a lot. Our top 4 seasonal snowfall records help indicate that. As we look at these numbers, most of them occurred within the 2010 decade. The only outlier was the 1938-1939 season. Now let's talk about the calendar year snowfall. 2019 was very close to 134 inches. That is the most on record. 3 of the total 4 stats listed here occurred in the 2010s decade too. The only exception was in the 1950s. This past season, we had just over 88 inches, so those numbers are down this year. When looking at precipitation stats for all of 2019, Rhinelander set a new record of 43 inches of both snow and rain measured in rainfall units. For this year, we were tracking slightly below average. The leftovers of Cristobal helped to make up for that. With all the water in the ground, that will be a problem for lakes both large and small.
Back in December 2012, January 2013, we had record low levels in the Lake Michigan-Huron Basin. Since that time, our lake levels have risen over 5 feet just in the last 6-7 years. So we've gone from a record low, now we're at record highs, and we've been like that since January, and those are expected to last into the summer.
According to the Army Corps of Engineers, the lakes usually go in cycles.
Lake Michigan, Huron, most people remember, recently from the late 90s to about 2013, a period of low water, but people also remember the very high water from the mid to late 1980s as well. And you can see trends in that as you go out in the, further back into the period as well.
Generally, the drop-off occurs in the fall into the winter months. One of the big problems we had this last year was we did not have that drop-off.
Looking at the data for 2019 and this year, Lake Michigan Huron are trending higher compared to last year. However, Lake Superior is down a little bit from last year.
As we go out in time, it's likely that we will cycle out of high water just as we have in the past when it's occurred before.
However, all lakes are still very high in their levels. Mother Nature holds the keys to what the lakes do next.
We've had record precipitation, the last couple of years, so all the lakes are pretty high. So we want people to exercise caution and keep an eye out. The soil saturation is pretty high, so if you get a significant rain event, it can't really sink into the soil. It runs off because it can't, the soil's already saturated.
The primary drivers of water levels is Mother Nature, and the 3 main variables that we're tracking are precipitation and evaporation, as you mentioned, and then runoff is another key component that we factor in.
There are other drivers besides those 3.
Air temperatures, surface water temperatures, ice cover. All of those other things do have a role in the impacts to water levels.
I'm here along Lake Emily in Portage County, where right behind me is supposed to be a beach right now. Clearly that beach is underwater because of a lot of rainfall over the past few years. El Nino or La Nina could help or hurt the situation with regards to the temperatures or how wet or drier things get. With us heading into a La Nina, things could get a little on the wet side.
The sea surface temperature and associated atmospheric patterns in the Pacific Ocean, generally between South America and Australia, have teleconnections that affect the weather in the upper Midwest in the United States and actually all around the globe.
When an El Nino or La Nina happens, we see our weather change. Let's focus on El Nino first.
When we have El Nino, it typically peaks during the Northern Hemisphere winter months. And so typically we see most of our, local effects from El Nino during the winter months and not so much during the summer.
The jet stream heads into Canada during the summer months regardless of an El Nino, La Nina, or a neutral pattern. So things get warmer either way. What about precipitation during an El Nino year?
Precipitation effects from it aren't quite as noticeable as temperatures, but we can see drier than normal conditions. So in general, you might see less of the cold air outbreaks in the heart of winter.
No El Nino is ever the same.
Each El Nino is different, so you can have above average precipitation with El Nino, and you can have cold temperatures with El Nino, but But certainly those are the basic trends during the winter.
La Nina can make things a little busy with regards to the jet stream.
It changes the polar jet stream such that it's a little bit more wavy, I guess you could say. And so what we typically get from that is we get more cold air outbreaks coming from Canada, more of that northwesterly flow.
But where did the names El Nino and La Nina come from? Both of the terms come from Spanish origins. The term El Nino dates back to 1983. It means the little boy or Christ child, since El Nino usually occurred around Christmas time. That part of the definition would later be updated to simply say that it causes unusually warm water off of the coast of South America. It causes issues with local fish and bird populations. The water is warm as a result of the trade winds stopping. For La Nina, it's the opposite of El Nino. It means the little girl. It's referred to as a cold event. It causes the waters off of South America to become colder as a result of stronger trade winds. Right now, we're in a neutral pattern, but a weak La Nina could develop.
What that could mean for our winter weather, just looking at some things that the Climate Prediction Center put out, is kind of equal chances for seeing above or below average temperatures and maybe a little bit of increased precipitations.
With lakes already high, this could keep the flood risk high.
We've been dealing with all kinds of lakeshore flooding issues when we have really strong storms moving through and pushing the water onto shore and things of that sort. So, we're kind of looking at, those hazards being potentially a problem again come this fall when we start to see more of those fall storms move in and we get the strong winds off the lakes.
National Weather Service in Green Bay said the lake levels did not drop off like they should.
Normally you see the curve like this. It rises in the summer when you get the precipitation, and then it falls in the fall and winter when you get the evaporation. Well, this last year, it rose in the summer, and then during the fall and winter, it really stayed kind of even. It didn't fall like it was supposed to. Now we're going into this season with record high levels.
Over in Green Bay, a simple wind change can cause flooding in the area.
Anytime we get an onshore wind, especially a northeast wind down the Bay of Green Bay, we've gotten significant flooding, Brown County, Oconto, and Marinette. So our main concern is anybody living along the lakeshore and even further inland, because the northeast wind actually stops the Fox River or causes it to reverse course.
And that expands the flooding.
It doesn't allow all the runoff or the river to flow into the bay, so it's backed up, so the city of Green Bay and downtown for several miles inland from the bay will actually flood.
Those impacts have caused issues.
We've seen issues with property damage, and beaches are being basically washed away. So we've definitely seen the impacts throughout the region over the last year or so.
As we battle the lakes, there are things we can do to protect the houses.
But they can take the proper precautions, or if they need to do something like build a sandbag wall or something, that they have time to do that. Especially as we're especially on Lakes Michigan, here on Superior, they are likely going to be rising for the next month or so.
So the jet stream has moved a little slower, so anytime it gets nudged in a certain direction, it tends to stay where it is at for longer periods of time. So areas like further out west that are in the ridging and stay drier longer, they've had more drought problems. Places like us who are in the trough tend to get rain after rain after rain, so we're wetter on a more regular basis.
We got into this mess with too much rain. It may take the opposite to solve this issue.
It takes time to, takes persistent dry conditions over the next months to years to really see some relief on the lakes.
In northern Wisconsin, I'm Devin Biggs for WeatherWatch 12.
Compared with other weather measurements that date back to the 1800s, El Nino and La Nina haven't been studied that long. It will be interesting to see as we lean towards La Nina that if this winter follows past La Nina years. When we come back, our top weather pick.
And welcome back. In July 2019, a severe weather event uprooted trees, caused damage, and knocked out power to over 150 square miles in north central Wisconsin. Who can forget that? As we approach the one-year anniversary, we take a look back. Number one on our list is a two-day severe wind event of July 2019. We took a trip down to the National Weather Service in Green Bay to review what happened.
One area that was hit the hardest was Elko in Lang Lake County, especially along Lower Post Lake. That damage was caused by an event known as a derecho.
Derecho is a widespread, long-lived, straight-lined windstorm with fast-moving thunderstorms.
Derechos form and travel across the upper Midwest and Great Lakes each year. For a region used to severe weather events, the National Weather Service says there was plenty unusual about this event.
Probably the thing that sticks in my mind the most, what was unusual for me, was we had that event on July 19th, and 12 hours later, we had another huge event further south, more towards central and east central Wisconsin.
They say the atmosphere is not supposed to behave like that.
Usually you need a day or two to kind of recharge the atmosphere, but for that event to happen at night, and another one to happen quickly the next morning was unusual as far as my perspective goes.
That proved to be a worst-case scenario for Elko. Last year, we interviewed Ben Mary, who is a seasonal resident in Elko.
My wife said to me, she says, we've been here for 38 years. And she said, it's like I don't even know where I'm at. She said, it's just unbelievable.
Mary was actually at his winter home in southern Wisconsin. Due to widespread damage, they couldn't get to their second home in Elko for several days.
We were out of power 6 days, so I didn't see any reason to come up. I couldn't get in my driveway. Matter of fact, this whole road was basically closed.
There was a confirmed tornado touchdown not too far away in Pelican Lake that was rated an EF1. That wasn't the only thing that caused damage. Meteorologist Phil Kermsky from the Green Bay National Weather Service used a pencil to compare their tornado and spilled water for the winds.
The pencil may produce a small area of damage, but spilling the water is kind of like the macro burst that happened. And if you look at satellite images, huge swaths of forest were flattened. So that was the main story. A small spin up in that event would not have produced as much damage as those huge swaths of macro bursts.
The measured wind from this event was on the higher end of known and measured wind events.
They can get 60 to 80 miles an hour, but we also can get readings as high as 100 miles an hour. There were some indications up north that they were 90-plus mile-an-hour winds from this event, so it was on the very high end of the derechos.
So we have microbursts versus macrobursts. The difference of the two lies within the damage.
We get microbursts, we get small areas of damage that you can't really see on satellite, or it's very hard to. But this one was so widespread and so severe that the next day when they did the satellite pass, we could see a huge swath of the area was totally flattened by the macroburst winds. So that was unusual to be able to see such a wide path of damage.
As we continue through our current severe weather season, they say everyone should remain prepared.
Always be aware of the weather. Never let your guard down. Stay alert to your weather radio or your local TV station for weather information, because things can change rather quickly, especially in the summer. So just have your safety plan in place, practice it and execute it when you get severe weather. There are several websites. Ready.gov has a lot of great resources for what people need to do to prepare for severe weather. They can go to our website, weather.gov/GRB, for information on what's going on with the weather, so they can keep track of when we're expecting severe weather and how bad it's going to be.
In northern Wisconsin, I'm Jeff Weller for WeatherWatch 12. Tyler, you and I were on air during that 2-day wind event back in July 2019. I remember looking at the radar with you and seeing winds just above the Earth's surface at 90 miles per hour. We knew then that if that wind made it down just a couple hundred feet, we would have some mass destruction.
And unfortunately, that is exactly what we saw. That wind was able to make it down to the surface. We were hoping while we were on air that it wouldn't happen, but unfortunately it did, and it caused lots of destruction across north central Wisconsin.
For sure. Nearly 150 square miles devastated back in July 2019. We want to thank you for joining us this evening from WeatherWatch 12. Have a great night.